Hello again, my fellow Jeti users, and this is one of the most requested subjects that I have received, and it is using the Bavarian Demon Cortex Pro gyro with your Jeti central box. I have important information for you that's not in the instructions about how the system works and some of the issues that you might run up against, but of course I have the solutions to them as well. I'm really pleased to be able to do this video because I am a total fan of gyros. I know some people are set against them, but in my opinion, having a model without a gyro is like having a car without suspension. This video is going to take quite a long time, and that long time may put you off using a Cortex Pro with your Jeti. Do not be put off. Now that I know how it works and what to do, I could have one up and running in moments. This video is long because I will be explaining the process bit by bit, also explaining how it can go wrong and what are your options for getting it to work properly. This video is not a substitute for reading the Bavarian Demon manual, and I mean the full manual, not just the quick start guide that comes with the gyro. In this video, we will learn how to set up the Jeti receivers and central box to work with Cortex Pro, how to set your Cortex Pro to work with Jeti, what are the potential problems integrating the Cortex Pro with Jeti and how to solve them, and at the end have a fully integrated system that is working properly. What I will not do is tell you how to set up gyros in general or how to set up a Cortex Pro as a gyro, things like its orientations and advanced settings. Read the manual. However, you program your transmitter to control it in the same way that you would almost any other gyro system, and from what I can gather, the default advanced settings in the Cortex work fine for almost everyone, leaving you simply to adjust the gain just like you would on any other gyro. However, at the end of the video I'll talk briefly about the Jeti 900 MHz in use with it, the Cortex gyro banks and Cortex heading hold mode. For this video, we have to give a big thanks to two people. Firstly, to Bernie Jones of Jeti UK for lending me the Cortex Pro and the central box. I have a standard Cortex in a model, but it's not the Pro, and it's been doing a very fine job for the last 5 years. And I have lots of central boxes, but all installed in models and not available to be used in a video. So without Bernie's assistance, this video would not be possible. Also, we must thank Danny Melnick of aeropanda.com in the USA. When Danny learned of my intention to make this video, he offered his technical help. Danny is USA distributor for Bavarian Demon and put much of Jeti through its certification for use with the American FCC, so he knows his stuff. We had a long phone call and I learned a lot about the Cortex Pro and about Jeti too. Without Danny's knowledge and help, I would have struggled to get the system to work properly, or even to work at all by just following the Cortex instruction manual. Now I understand why so many of you are asking for help. So we all owe Bernie and Danny a beer. Okay, drink your espresso, have a chocolate hobnob biscuit for some sugar for your brain, and we'll dive into Jeti and the Cortex Pro. Well, what is a Cortex Pro and why is it so special for Jeti? You can use a Cortex Pro like a standard Cortex or any other third-party gyro by taking the fly leads, and Bavarian Demon provide you with this monoblock plug with lots of fly leads, to your central box, and then
inactivity alarm.
Plug a few servos into the Cortex and off you go. The point of the Pro version is that you can connect it between the receivers, so from receivers to the Cortex, to the central box, and that reduces the amount of wires, but it also gives you up to 16 stabilized channels, although it will pass through the full 24 channels from your receiver. And most importantly, it then appears in Jeti Device Explorer because it's an EX bus device. And that means you can adjust its internal settings from your transmitter instead of needing to connect it to a computer. Make sure my little table doesn't collapse. Good. Now, There is a little bit of an issue with a Cortex Pro, and it is that the secondary receiver hardware inside the Cortex is not bidirectional, meaning that it does not allow the telemetry from the central box's receiver 2 socket to get back through the Demon Cortex to the second receiver. Therefore, if receiver 1's aerials have lost communication with your transmitter, say because they've been shielded by something like carbon fiber or metal, and there's no telemetry coming back from receiver 1, you still have control of the model, but the Cortex is blocking telemetry on the second channel to receiver 2. So your telemetry fails from any sensor that's plugged into the central box and from the central box's own values like its input battery voltages. You still get telemetry generated from the receivers, so your receiver 2 will still give you its A and Q values and its voltage. Any displayed telemetry on the transmitter screen will flash to indicate it has been lost. It will not update live, and of course nothing for that period would be logged for review later, other than things like the A and Q values that come direct from the receivers. If you have any telemetry controls such as an M bar putting the gear down on low air pressure, they might misbehave. You can see my video about M bar gear failsafe to find out how to make a telemetry control behave when it loses telemetry signal. What about any alarms you've set? Well, I created a low voltage alarm from the central box, but it was not set off by the loss of telemetry. It seems the transmitter does not treat no value as the same as a low value, so at least you might be spared from having alarms going off at the loss of telemetry. If you have any voice output on a switch, it will just not say anything when the telemetry drops out. Okay, is this a problem? How often and for how long does receiver 1 lose its telemetry communication with the transmitter? Well, in my opinion, I would say that if it happens often, or for more than a couple of seconds at a time, then you have a more important problem to solve than loss of telemetry. You have an installation problem causing both aerials to be shielded at the same time, or shielded enough in a noisy radio environment that telemetry from receiver 1 doesn't get back to the transmitter. It doesn't necessarily mean that receiver 1 is not getting the signal from your transmitter, because that is a stronger signal than telemetry, and the telemetry ought to fail before the control from transmitter to receiver fails. But we should not be using the second receiver as a band-aid for installation problems with receiver 1. So you should have got things into a position where the telemetry from receiver 1 only fails occasionally and briefly, so that the lack of telemetry from receiver 2 that the Cortex Pro causes is a rare and short-lived issue. Remember, you will still get telemetry generated by receiver 2. You get its A and Q values and its voltage. What you lose is telemetry data of the central box itself, such as its battery data, and of any sensors plugged into the central box. How do we deal with this? Well, I see three options. Number 1, if you prefer using default transmission with the backup receiver being set as a cloned receiver, and some people prefer this, you have this issue permanently anyway, because a cloned receiver does not send telemetry, not even its A and Q values. The transmitter does not know that the cloned receiver exists. So you can go ahead and connect everything up as shown in the instruction manual anyway. Number 2, if you use double path, but do not use any telemetry at all other than A and Q values, or you're not bothered about the occasional dropouts, then again there's nothing to worry about. Go ahead and connect as shown in the instruction manual. And number 3, if you use double path transmission and want no breaks in telemetry, or are worried about the effect on telemetry controls that you've programmed, what do? Well, we can solve it. We simply daisy chain the secondary receiver to the primary and connect only the primary to the Cortex Pro, and then one connection from the Cortex Pro to the central box, receiver 1. The channel through the Cortex Pro on the primary receiver is truly bidirectional, so it will get telemetry. But receiver 1 will block the telemetry getting back to receiver 2. So we can also connect the secondary receiver straight to the receiver 2 socket in the central box. So if the primary loses a signal, it takes it from the secondary. The output carries on through the cortex and is stabilized down to the central box, which is what we want. But since the primary RX is getting only an input and not bidirectional data with the secondary, it blocks the telemetry getting back to the secondary, which can't send it back to you. But the central box receiver 2 socket is passing telemetry data direct to the secondary receiver. One minor limitation this imposes is that the RSAT2, which is popular in many countries, cannot be used as a receiver because both receivers will need 2 sockets capable of using XBus, and the RSAT has only one capable of XBus. So we need to use any receiver that has at least 2 sockets capable of XBus, meaning a REX receiver. I believe that the REX 3 is the minimum receiver that can do this. I don't have a REX 3 to test, so I cannot guarantee it, but I'm pretty sure they do have enough XBus ports. And I'm going to use these REX 10 receivers to demonstrate it all. I'll use the REX 10s with the parallel programming at the start. I could use the RSATs. If you're happy to wire them up in parallel and suffer the very occasional dropout of telemetry, you can use as a minimum the RSAT. But if you want to daisy chain in order to guarantee no dropout of telemetry, then you need to use a REX receiver. But we'll come to all that. So first I'm going to show the parallel connection using 2 receivers using the REX 10s, the way that is shown in the Cortex manual, but that might have telemetry dropouts. Or you can use any receiver that has one XBus port from the RSAT upwards. I'll still use the double path method, but apart from the binding process, the setup is pretty much the same if you want to use a cloned receiver instead. Then, once we've done all that, I'll just show you the slightly different way to do it with the 2 receivers daisy-chained to get unbroken telemetry. So first, let's get our Jeti set up. And I'm going to make sure that the Jeti system is properly set up before I even connect the Cortex Pro into it. We need a control and a channel for the gain. I'm going to use P8. So we have a quick look in here, model, functions assignment. I've got P8, the rotary control, assigned as gyro. Yep. And of course, it's then assigned a servo to it. There it is. Channel 5. Okay. As with many gyro systems, the Cortex Pro uses the servo center signal as meaning off. Values below the center increase the gain in bank number 1, and values above the center increase the gain in bank number 2. It is no longer the case that one way is rate or normal mode, and that the other way is heading hold mode. Although that is the default setting of the Cortex Pro, each bank is independently set by you, so you can make them both normal mode, both heading mode, or various mixtures. If you've seen my other gyro videos, you know that I have a gyro master switch that my brain has learned in case I ever need to switch a gyro off in a hurry. So I'm going to set that switch in the gyro dual rate as 0%. Here's my gyro switch, labeled gyro. I go into fine tuning, dual rate expo, gyro. I set the switch, and when I have the gyro switched off, watch the dual rate goes to 0, and that forces a center value. So as I rotate P8 knob, it can't go up or down, it simply sits going along there. And that will force the Demon Cortex to its center or off position. I am going to go through the double path binding in this video yet again, because it can catch some people out as they don't realize that they're binding the second receiver to the primary transmitter, thus overwriting the primary receiver that they have just bound. Now, the wiring connection of primary and secondary receivers to a central box and also to a Cortex Pro is always important, and that's why I label the receivers so that I know which I've bound to the primary and which I have bound to the secondary. You cannot plug them in at random. The primary must go into a specific socket in the central box or in specific socket in the Cortex, and the secondary must also be plugged into its specific socket. Right, let's have a look at binding them. Menu, Advanced Properties, Wireless Modes, Trainer. I'm going to change it to double path. Loss of both receivers is how I set it. It stops it chirping away if one of them momentarily dips out on telemetry. Otherwise you can get a lot of alarms that just worry you, perhaps needlessly. I'm going to pair the primary module. So I shall press the button to start that running so it knows what it's doing. Get my little battery. Take my receiver that's labeled number 1. Power it up. We'll use this receiver. Yes. Lovely. Now, unpower it. Come down here.
Signal lost.
And set the second
Signal
one running
lost.
before you power up the
Signal
secondary
lost.
receiver.
Signal lost.
This is where people tend to...
Signal lost. Signal lost.
Quieter her down.
Signal lost.
This is where it tends to go wrong for people,
Signal lost.
as they power up the secondary
Signal
receiver
lost.
before they've
Signal
got this
lost.
going, and they end up
Signal
repairing
lost.
it to the primary. So we'll
Signal
do
lost.
that. Get my battery. Plug it into receiver number 2. Really use this? Yes. There we go. I now have my 2 receivers bound. Okie doke. I'll just briefly now power up receiver number 1 as well. So both of them are running. Say okay to that. Once you've got them bound, make sure you really have got 2 different receivers genuinely bound in this system. For that, we go to System, right down to the bottom, Info, and it will tell us. Can you see here we've got TXP and TXS. Transmission primary module, transmission secondary module. And look at that. The serial number of the receiver, well, it's not serial number, it's a sort of coded registration number, is different on each one. So we've got 2 of them, and they are different. That's the important bit. If we'd made a mistake and managed to bind the secondary to the primary over the first one we'd done, that would be blank, and you'd only have one in primary. So we can see now that, yep, the system is bound to 2 different receivers. That's happy. Next, we have to set up our receivers. For that, we come to Model, Device Explorer, and here we can see them both. There's the primary, there's the secondary. Let's set up the primary. General settings, output period will be auto. If you're worried about, ooh, my servos won't handle auto, the output period for your servos will be set in the central box. When the receivers are just providing a signal to the central box, set them to auto. Okie dokie. Come down here. Now, alternative pin config is what we want, because I'm going to use servo socket 8E2 as my output. They've got E1 and E2 on these receivers. So I go into alternative pin config and I scroll down. There's 8E2. I don't want it to be a servo, so I go in here and I tell it to be XBus. Okay to that. And one other thing I need to check, and that's the failsafe. Failsafe must be disabled. So always disable the failsafe when you're running 2 receivers to a central box. Okie doke. So that one, we've set the XBus, we've disabled the failsafe, the timing is auto. That's good. That's that one done. Come down to the other one and we'll do exactly the same. General settings, output period auto, failsafe must be disabled. It's all handled in the central box. And the alternative pin config, 8/E2 is XBus. Okay, we're done there. Now I'm going to go ahead and connect them up to the central box. So I will remove the separate battery power I've got in them, which will generate an alarm for a moment.
Signal lost.
There we go. I'll just cover up the speaker
Signal
for a second.
lost.
And
Signal lost.
it's important that the receiver
Signal lost.
that's labelled receiver 1
Signal
goes into
lost.
the R1 socket
Signal lost.
of the central box.
Signal lost.
Receiver 2
Signal
goes into the
lost.
R2 socket.
Signal lost.
So that the primary is in
Signal
receiver 1
lost.
and the secondary is in receiver
Signal
2.
lost.
Now we can
Signal
power up the
lost.
central box. There we go. And whoopie-doo, central box has appeared. All the ticks have come. That's good. So the system's seeing them all. Okay, now central boxes and any other devices you've got which are XBus must all hang off the primary receiver. If they're hanging off the secondary receiver, you have done something like bind them the wrong way round, mislabeled them, plugged them in the wrong way round. So go back to the start and try again. It is possible to get them hanging off the second receiver. That's a mistake. They must hang off here. Now then. Okay, let's see if our test servo works. There's our little test servo. Yep, so something at least is getting through the central box. Right, let's prove that we've managed to get the whole setup working properly. We'll disable the primary receiver. Come out to the front here. We can see we're both systems getting A9s and 100%. I think it's dropping there maybe just because of the proximity of all the aerials to the servos and bits of running everything a bit close here. And so we'll disable the primary. So we go into Advanced Properties, Wireless Modes Trainer. We press this little button here for the transmitter aerial symbol. And we'll disable the primary module. Say yes.
Warning.
Okay, it's going to be a bit annoying. We'll deal with those in a moment.
Warning.
Come out of here, and we can see that the primary has indeed lost its
Warning.
signal. Look at the servo. Is it still working? It is. So our wiring up of the secondary has worked. Come out of here, back to Advanced Properties, Wireless Modes Trainer, and switch it back on. Go back into it.
Warning.
Disable the secondary module. Yes. Come out of here. Look at that. Our secondary has gone off, but that servo's still working. Good.
Warning.
Go back to the Wireless Modes Trainer, switch it back on. Okay. Now, if the servo does not work when one of the transmissions is disabled, and it would usually be when you disable the primary, it doesn't switch over to the secondary, then you've got something wrong. Go back and check everything again. Now then, let's go into our central box and get it set to work with the Cortex Pro. General settings. You can see the receiver inputs automatically set themselves as XBus. They detect it. Output period here, you would set to suit the servos you've got. Even, I think Jeti themselves suggest using a specific time with digital servos. If you've got even one analog servo, then you want to use sort of 17, 18, 19, 20 milliseconds. I'll set it at 17, although my little test servo here is digital. Come down here, RX alarm enabled. That was the warnings we've just been getting, saying warning, warning, although just telling you warning, warning isn't very helpful, is it? You don't know what's going wrong. When it recognized it was getting no data on one of the receivers, I find that a bit irksome. I'm going to disable it. That's purely your choice. Okay, now this one here, the switchover strategy, this is vital you get this right with the Demon Cortex Pro, because if you select mixing, which is the switchover strategy I always go to with a central box, if you select that with a Cortex Pro, the servo will be very jerky and unresponsive and frankly unusable. So you must choose one of the timeouts. I prefer the shortest timeout. This is a menu setting that determines how the central box behaves when it recognizes it's not getting a signal anymore on receiver 1. How long should it take to switch over to receiver number 2 socket. So obviously I like the shortest one. There we go. So remember, do not use the mixing switchover strategy with Cortex Pro. And finally, I'll prove the failsafe. Back into here. Servo failsafe. I'll put it on out pin 2, might as well, because that's the one my servo's in at the moment. Set it to failsafe. Set failsafe position now. It's there. Apply changes, yes. Okay, so that's my servo. Okay, now I can come out of here now. I will go back to advanced properties, wireless modes trainer, back into the transmission, disable transmission completely, say OK. Do you want to disable it? If I hold that servo over and disable transmission, then it should fail safe.
Signal lost.
There we are.
Signal lost.
Okay. Right, it's been a little while to get to this point. You might think I'm belaboring it a bit, but we have proved that our entire Jeti system is working properly before we think of introducing the Cortex Pro into it. So if we were to encounter a problem from now on, we know it's something to do with our integration of the Cortex Pro. If you just try and put the whole system together at once and then try and do everything and something doesn't work, you're rather puzzled as to where it's going wrong. Okay. What do you get when you open up the box? I'm going to just switch off the central box for a moment.
Signal lost.
Clear that message. Okay. You get one Cortex Pro, and you get the little bundle of patch leads in case you wish to use them, your little shorting out plug, binding plug, programming plug, whatever you like to call it, and a quick reference guide. You will need to provide three of these male-to-male patch leads. They don't come with the Cortex. And maybe a Y lead as well. Okay, we'll get to this. Now, in amongst all the writing on the Quick Start Guide, there is one little sentence, and for the moment it's the only one you should read, although you can come back to the Quick Start Guide later if you wish. It says, using Jeti, it's important to stick to the connection advice in the main manual. Well, I searched inside the box, but surprise, surprise, there is no main manual. So Google for Cortex Pro manual, and you'll be taken to Bavarian Demon's webpage with all their instruction manuals. Now, the important bit is on page 5, and it says, route a standard patch cable from any central box servo output port to port 4 on the Cortex Pro. Hence, here we are. There we go. Port 4 on the Cortex Pro, one patch cable, which I am going to plug into any unused port. Let's pick that one at random on my central box. Now, the reason for this is that Jeti central box receiver sockets are very current limited. They are not on the main power bus as you might expect them to be. So Bavarian Demon wants to guarantee a good power supply from one of the central box's servo sockets. If all the servo sockets are being used for servos, then you can simply use a Y lead to connect both the servo and the Cortex Pro to the central box. I suggest you pick a servo output channel that is going to be a low current one and not one that's being used by high power servos on the flaps, for instance. But now for another little twist to this setting up. Bavarian Demon want the primary receiver plugged into port B, and the secondary plugged into port A. Not, as you might have expected, the primary into A and the secondary into B. Also, output socket 6 goes into central box receiver 1 and output 5 goes into central box receiver 2. Again, seemingly reverse to what you might expect. So I'm going to do that. Let me shift the camera along just a little bit. I will unplug my receivers from the central box. Okie dokie. Now then, remember this, what it said. The primary, receiver 1, goes into port B, not port A. And the secondary, and you remember you have labelled them, haven't you? So you know which one is which, goes into port A. It is important these are the right way around. And now the output lead 5 goes to receiver 2. Okie doke. So we go around here and receiver 2. And output 6 goes into receiver 1. There we go. Okay, at last, let's power up the system with a Cortex Pro in it and get it set up.
Inactivity alarm.
The servo's unhappy because it's right next to the transmitter aerial, so I'll move it a little bit away. There we go. Okay, and there we have our little Cortex Pro. Nice big bright red light on it, so it's getting power. Now, your model must already be set up properly on the transmitter. Do things like set your dual rates to their high rate and so on. Please do read the Cortex Pro manual because there's little details like this that you need to do. So first, we need to teach it that we're using Jeti X bus. You power up the central box. We've done that. Take your little programming plug and put it into the programming socket marked prog. Then you watch the fast flashing blue light, wait for it to change to a slower flash, and that tells you that it's worked out it's using Jeti X bus. So that's it. You switch it off and remove the plug. So here we go. Get past all these wires. Come on, out the way. Righty-ho. Okay, ready? Here we go. Oh, I missed it. There's enough of a gap there. You can actually put it down the side of the pins. Here we go again. There we go. Fast flashing blue light. And there we go. The change to the slower. And it has a little sort of double blink. But as you can see, the overall flash rate is slower. That tells you it has now decided what data system it's using. Because remember, apparently there are other brands of radio. My goodness. And they will have things like S-Bus or different sorts of outputs. So not everybody is using Jeti X bus. So now it knows what it's doing. We switch off the central box. And we can remove
Signal lost.
the programming plug.
Signal lost. Signal lost. Signal lost.
Clear that message for a moment. Now, the instructions don't mention this step, but I like to power it on again now, just to make sure that it has worked, that it's appearing in Device Explorer, that it's showing below receiver 1. Does the servo work? So, power on again. Receivers are bound. Let's have a look in Device Explorer. Yeehaw! A Cortex Pro. That's looking good. And does our servo work? Yes, it does. All that tells us now, the fact that it's appearing in Device Explorer and the servo's working, it does appear to have correctly picked up Jeti EX bus. Okie doke. Next step. Right, now we need to teach it what the controls are. So we switch it off. Here's my little switch cable. There we are. Switch it off.
Signal lost.
Clear out our error message. Now, first, this time, we put the plug in before switching on. So in goes our little programming plug. And then we'll switch it on and follow the sequence of flashing lights that you can see on the quick reference guide or in the main manual. And it will also bump the servo at the same time. RTFM, which stands for Read the Flipping Manual, or the Quick Start Guide. So once we get it going, we're waiting for a long series of flashes, and then we'll get a double green flash and or a servo bump. We then put on right aileron, full right aileron stick, and try and just be pure aileron, try not to get any elevator in with it. So pure right aileron and hold it there until we get a single flash. Then we put full left aileron and hold it there. Then at the double flash we go down elevator and hold, single flash up elevator and hold, double flash right rudder and hold, single flash left rudder and hold, double flash we rotate the gyro gain knob. And then we should get a long string of green flashes. When that happens, we can pull out the jumper plug and switch off, and it will know what its controls are. So let's have a go and see what happens. Can the camera see the little light there? Yep. Ah, the joys of trying to do everything on your own in your workshop. Okay, here we go. Long series of red flashes. Double green and a servo bump. Full right, hold. Single and a bump. Full left. Down. Up. Right rudder. Left rudder. Aha. This does happen sometimes. You manage to miss the sequence. So we'll do it again. We will power off.
Signal lost. Signal lost.
Power back on and
Signal
start
lost.
it again. Full right. Full left. Full down. Up. Rudder right. Left. That's it. Rotate the P8 knob. Back to the middle. Leave it alone. And now wait. I have sometimes it starts the final green flashing immediately. Sometimes it takes a long, there it goes. Long green flashing. It's happy, it's found everything. So we can remove that and switch it off for a moment. There we go.
Signal lost. Signal lost.
Righto. Okay, it should now all be working. So let's switch it back on and see what we get. Let it boot up. It thinks about it. There we are. It's turned to its final solid colour, which is green because we actually rotated the knob into one of the banks. I don't know if you heard the servo give its little double twitch there. All your stabilised surfaces will give a lovely little double twitch when your Cortex is up and ready to use. Until they do that, do not move any of the controls. Don't try swinging the model around. Just switch everything on and wait those few seconds till you get that double bump. Then off you go. Now then, if it's got everything correct, then as I rotate the gain knob, we're to the right, we're in the green. I'll rotate it anti-clockwise. As we come to the middle, it should turn red. Ooh, there we go. And if I rotate further around to the anti-clockwise than that, it should turn a sort of yellow colour. There we go. So yellow, bank 1 to the left. Red is off. Green to the right. Lovely. And if I pull my gyro off switch, hopefully it will turn red. Yes, it's gone off. I can rotate P8 all the way and it's locked in the off position. So it's picked up the gain tuning knob correctly. And this is where you can now go off and check that all your settings are correct. Just for an instance here, I've got the servo plugged into channel 2, which is aileron. If I move the aileron stick, there goes the servo, and the gyro is red, it's off, so the servo should not respond. It's not. If I turn the gain up a bit and rotate the gyro on its roll axis, oh yeah. But if I rotate the gyro in yaw, nothing happens, and if I rotate the gyro in pitch, nothing's happening. But I think you can see from the edge of it, yes, it's certainly responding there. Good. So on your model, of course, you now have to check all your control surfaces are indeed being stabilized in the correct direction. But basically, we're there. Now, we've previously proved without the Cortex in the system that it all worked if we disabled the transmission modes. So let's do it again just to prove that it's getting through the Cortex. I'll just disable the primary one just for the moment to prove it. Disable transmission, yes. You can see it's lost it there. Where's our little servo? There he is. And if I turn on the gain and rotate the gyro, yes. So with the primary off, the secondary is still getting through and it's all still being stabilized. And that's it. So just do all your careful checks that everything's running the right way, and that's it. You are ready to go and fly. Okay, what if you want the unbroken telemetry option? Well, now we daisy chain the secondary receiver into the primary receiver. So we go into Device Explorer, and both expander ports on the secondary must be set to X bus. We've already set the one that we're using. There it is there. Find the other expander port and set it to X bus. And say OK to that. Now in the primary receiver, the other expander port must be set to X bus input / backup. Why has that gone off? Well, I found out why that had all gone off, and maybe you'd spotted it from earlier. Like a muppet, I managed to leave the system in TX1 disabled when we were doing previous testing. It took me a little while to find out why things had seemingly gone off, but anyway, there we are. Switch TX transmission module 1 back on, and we're here again. Okay, so we've set the secondary, both of its expander ports, to be EX bus. But here in the primary, see, we need the other port to be an X bus input. So there's expander port 2 X bus that's sending out to the Cortex in the central box. E1, not X bus, but an X bus input / backup. because that is where we're going to plug in the secondary receiver. Okay, to that. Okay, so now what we're going to do is disconnect the secondary receiver from port A and plug it into the primary receiver E1 port, which is the one we've just set as the X-bus input backup. There we go. So what we've got so far is secondary routes through the primary. The primary alone is plugged in to socket B of the Cortex Pro. But we now need central box receiver 2 not to be connected to the Cortex, but to be connected into the other X-bus socket here. So there's the plug. It's in central box socket 2. I remove it from the Cortex Pro. Out you come. And I'm going to plug it into the other X-bus socket on our secondary receiver. There we go. So how will the system work now? Well, the central box will run off its socket receiver 1 until it finds no data on receiver 1, and then it'll go to its socket receiver 2. But all the time it is passing telemetry data out on both sockets, the socket 2 as well as 1. Now, if all is well, receiver 1 is working. Both receiver 1 and receiver 2 are sending back telemetry to you. If receiver 1 loses its incoming signal from the transmitter, it takes data from receiver 2, passes it on through the Cortex into the central box receiver 1, so the central box doesn't need to switch to its socket receiver 2, but it is sending the telemetry data straight back to receiver 2, which can then send it back to your transmitter. So like we did with the parallel setup, test your system by disabling each transmission module in turn, but temporarily disconnect the central box receiver 2 socket from receiver 2, in other words the one we've just plugged in, when you disable transmission module 1. Otherwise, what could happen is that you end up just getting data direct from receiver 2 down to the central box socket 2. So we need to be sure that you're getting the data from receiver 2 going through receiver 1 and then through the Cortex, and not just via the direct cable. And you can see that the telemetry on your front screen will drop out and start flashing when you do that. Make sure you still have control and stabilization. Now plug that patch lead back in from central box receiver socket 2 into the direct connection to receiver 2 itself, and see the telemetry comes back. Okay, where do you plug in your 900 megahertz backup receiver? Into the primary or secondary receiver? No. If you're using the daisy chained receivers, port A of the Cortex is now free. Do you plug your 900 in there? No. The different data rate of the 900 compared to 2.4 gigahertz will cause problems. You plug your 900 direct into the central box E1 receiver 3 port, which is capable of dealing with a 900. So let's have a look at the Cortex Pro in Device Explorer. There we are. Servo type, I think that's where you're plugging servos direct into the Cortex itself rather than this method. Here is where you would set the orientation of the Cortex Pro. Dual RX, it sort of defaulted to on, so of course we leave it. And then there's a couple of more menu settings down here, and that's it. So bank setup, here we go in here. Here's your two banks. The yellow and green is referring to the colour of the LED. So if I rotate the knob anti-clockwise, it goes sort of yellow. It's a very greeny yellow, so you're in bank 1. And if I rotate it to the right, it changes to green, so you're in bank 2. Now, what it's saying here is that in bank 1, aileron will be normal mode. And then it gives you some numbers. But to be honest, unless you really know what you're doing, I would never bother changing those. The settings that it comes with is stock work beautifully normally. And so elevator would be normal mode as well, rudder would be normal mode as well. You can change them, just press that. You can have it off, normal, or hold mode. And bank 2 has been set up. It defaults into hold mode, but again, you could change it to normal. So you could end up, if you wish, with both banks being normal mode, both banks being hold mode, or you can mix and match. For instance, here aileron is hold, elevator is hold, but you can change rudder alone to be normal mode. Interesting. That's the way you certainly prefer to fly in hold mode. Now, in normal flight with a Cortex, do not use heading hold mode. The instruction manual says do not use it for landing or takeoff. Use it only for things like hovering, those sorts of stationary 3D maneuvers. You might think you would try my automatic mode switching that I showed for the Jeti Assist gyro, because you can get it to switch between the normal mode bank and the heading hold bank. But the advice I have received is do not do this with a Cortex. Over the years, I have read on internet forums, and I've just been told again recently by Danny, that the Cortex in heading mode is just not that nice in normal flight. And as I say, even the Bavarian Demon Cortex Pro instructions just say use heading just for things like hovering. Also, it may have quite a big glitch when switching between normal and heading modes, so you don't want that to be happening in your flight. Danny Melnick tells me that most people who use a Cortex for hovering don't even put it into heading hold mode. They use normal mode with a very high gain. Okay, and we'll finish off with just a couple of very important points. One of them is really safety critical. If you ever again teach it the first step where it learns that this is Jeti X bus, or you're changing it to something like Futaba S bus or whatever, it loses the next step where you taught it the controls. So you must teach it the controls again. Otherwise, you're obviously going to have major safety issues once the gyro kicks in. And the other issue is that when you're teaching it the controls, then it actually learns that through port A of the Cortex, which is the secondary receiver input. That's fine if you're running the two receivers in parallel, but if you're using the second method I showed, where we're running the two receivers daisy chained in series so that you don't have any loss of telemetry, then of course you plug that into port B of the Cortex, because that's the primary receiver port. But if you're already running these in series and you get to the point of teaching the Cortex the controls, just plug it into port A. And that's where it learns the controls from. Then you can plug it back into port B, or simply run the two receivers in parallel for a moment in ports A and B. Okay? And that's it. I hope this has been a big help. So go out and enjoy your Cortex Pro with Jeti and have great fun with how a gyro really improves the enjoyment of flying your model. Thanks for bearing with me through this quite long video.